Well, thank you for joining us. I'm now joined by Nora Luetzgendorf, a scientist with the European Space Agency working on the James Webb Space Telescope. And today we just got the first images. Nora, can you tell us what we're seeing in these first few images?
So those images that we released today, they show a lot of very different objects. So here you can see a deep field and a galaxy cluster in front of it, a big gravitational lens that is lensing the light behind it. And this image is extremely deep. We haven't really seen that deep of an image in the infrared like this. And we only observed this for 12 hours. So it was a really, really quick shot in our sense. So it's amazing.
Yeah, and so the James Webb is an infrared telescope. Can you tell us what that means?
That means we are observing in the infrared wavelength. That is a longer wavelength than the visible that Hubble was doing. And with this, we are able to actually look through gas and dust clouds, do those things that Hubble wasn't able to see, and look inside those gas and dust clouds and look at stars that are just being born or supermassive black holes. Here you see a great example of one of those stars that are born. They're in those big clouds. And that's going to be amazing with Webb in general.
Honestly, views like that are just pure magical. Now, of course, it's the most powerful telescope ever constructed. What are some of the future observations we're going to see with this?
Well, we're going to look at the very beginning of our universe, when the first stars and galaxies just formed, like right at the end of the Dark Ages. We will look for planets that are outside of our solar system. We will look for life on planets, on those parts of the universe. And we will look at the birthplaces of stars and planets and supermassive black holes inside galaxies and see how they form and interact with their galaxies.
Now, you're one of the near-spec instrument scientists. What are some of the things that you're most excited to see with James Webb?
Well, I'm a really big black hole fan. I'm a black hole geek, so to say. I'm looking forward to see the supermassive black holes and to understand how their jets work, how their accretion inside of the galaxies work, how they grow, how those really, really big, massive black holes grew that quickly at the beginning of our universe. And this is something that Webb will be able to answer.
Well, Nora Luetzgendorf with the European Space Agency joining us. Thank you so much for your insight. We hope you have a great day.
Thank you.
We're joined now on Weather Nation by NASA's chief scientist of the James Webb Space Telescope mission, and it's a great pleasure to have you on here. First off, these are incredible images that we've seen. What's the first thing that pops out to you that gets you excited?
Well, just how inspiring they are. So I knew what we were going to be able to see with James Webb, but actually seeing it is really just, it's inspiring and it's impressive. So we're seeing the full range of the capabilities of the telescope, and getting to see those images and see what we can do is really impressive to me.
And they truly are just gorgeous images out there. We've got planet-forming regions. We've got ancient galaxies warped by space-time. What are some of the things that we're going to learn from these first images?
Well, so the first images are demonstrating the full range of capabilities. So we have the deepest infrared image of the universe so far. We have an image of a stellar nursery, so places where stars form. We have an image of a star dying in the cloud of gas that surrounds it. We have an image of a set of galaxies that are interlocked and moving together. And we have a spectrum that's showing us the atmospheric composition of an exoplanet.
And with that exoplanet, we're starting to see some of the details from that it contains water. What are some of the implications that we can use Webb for, that we could see for maybe outer planet life?
Well, so one of the things that Webb can do is see what the atmosphere is made of. And so the planet that we've shown here, the spectrum, you see water. It's a hot planet, so it would be more steam than liquid water. But Webb will also be able to tell us if an atmosphere has carbon dioxide or methane or other gases in there. And if you know how far a planet is from its star and what its atmosphere is made of, you can learn more things about it.
And so James Webb is an infrared telescope. Now, the Hubble telescope is sort of the gold standard that we used to know of space telescopes. What is the difference between the two?
So James Webb and Hubble, they're both great telescopes, and they're showing us slightly different things, both by the wavelengths that they're observing. So Hubble goes some into the infrared, but mostly primarily focuses on the optical and the ultraviolet. James Webb goes further into infrared, so different wavelengths show us different things. And by looking in the infrared, we can see through clouds of dust and gas and see the galaxies and planets that are behind them. They're also, Webb has a larger mirror, so it can see back further in time, and it's orbiting at a different spot than Hubble.
And so you said that it's got a larger mirror. Why do we need such an enormous telescope to see so far back?
Well, the larger the mirror, the more light it can gather, and so the further back in time that it can see.
Okay, so when we're seeing this this much larger telescope, we're getting so much more information. What are some things that we couldn't see with Hubble that we might be looking at as a future target?
Well, some of the first images, we saw some of them with Hubble, and now we have them with James Webb, and you can compare them. So the Carina Nebula, this stellar nursery, you can look at the image from Hubble and the image with James Webb, and what you see is a higher resolution image. You can see more of the detail, and then also more things in there because we're seeing further back. Also, when you look at them, since Webb can look back further in time, it can see the lights from the first galaxies, so earlier in time than what Hubble could see.
And in that first image that we saw released, it had just numerous galaxies in the background. How old are we looking and how far away?
It's looking more than 13 billion years back in time. In total, with some of them, James Webb can look back 13.5 billion years to a mere 300 million years after the universe formed.
So it's got to be really, really satisfying to see some of the first light that was ever emitted by some of these galaxies, right?
Yeah, it's super exciting as a scientist, and also just getting to interact with the team who've worked on this for so long. There's thousands of scientists and engineers that have worked for decades to get James Webb to where it is now, and now we get to see its science.
And I always remember hearing that new technology had to be made for James Webb to operate. What are some of the main instruments that we use on James Webb?
Well, so there are a number of different instruments, and they allow us to look at different things, so different wavelengths and other aspects of it. And some of the technology that's used for James Webb has also been used in other applications. We take what we learn when we're developing sensors for one telescope, and we can use them for other things.
And so going forward, what are some of the things that we want to use James Webb with in the future?
The James Webb will allow us to explore every phase of 13.5 billion years of cosmic history. So we can answer questions like, how do galaxies form and how do we fit into the cosmos? And there's a lot of science planned for it. Today's just the first day of James Webb images, and we'll have a lot more to come.
James Webb, sort of the new standard on galactic imagery, universal imagery. Where can some of our viewers go to see some of this imagery?
So everything's on NASA's website, so nasa.gov/JWST.
Kate Calvin, Chief Scientist with NASA, working on the James Webb Space Telescope. Thank you so much for joining us here on Weather Nation.
Thank you so much for having me.